Hello geometry students, this is Miss Mochizuki, and today we're going to learn about the volumes of pyramids. How do we find the volume of a pyramid? Well, if you take a look at the shape over on the right, you have a triangular prism, and you can see that the base is KLJ and on the bottom and base on the top is NPM. So you can divide it into three separate triangular pyramids. You can go from N down to L up to M, and from K and then back to K, and then you can go from K to L to M to J, and you can go from N to P to M to L. So those three pyramids can actually be fitted together in order to make that one big triangular prism. And by Cavalari's principle, triangular pyramids 1 and 2 have the same volume, and similarly, using pyramid R, you can show that triangular pyramids 1 and 3 have the same volume. By the transitive property of equality, triangular pyramids 2 and 3 have the same volume. Therefore, all three of those pyramids must be 1/3 of the volume of a prism. So why did we learn that? Because that essentially is going to give us the formula for the volume of a pyramid. The volume V of a pyramid is 1/3 the base area times the height. So it's 1/3 BH, B is the base area, and H is the height. Notice on the pyramid on the left, you can see the height is in the inside of the figure, but on the pyramid on the right, the height is drawn on the outside. It has to be perpendicular to the plane containing that base. So 1/3 base area times height is what we need to remember. So now we're going to try to do a couple of problems. So let's start off with example 1A. We're going to find the volume of this pyramid. So if you look at the pyramid, the base has all four sides marked congruent. Each one of them, therefore, is 4 meters. The height is 2.4 meters. So what we need to know is what the base area and the height are in order to find the volume of the pyramid. Well, the base is a square, and a square has one side length only, and so the base area is simply going to be 4 squared, which is 16 meters squared. Since the base area is 4 squared, it's going to be equal to 16 square meters. So the volume, recall, is 1/3 the base area times the height. So it is 1/3 16 times 2.4, which is 12.8 cubic meters. Now I'm going to give you some time to work on problem B yourself. See if you can get this one done, and I will be back in a minute. Okay, so the first thing we need to do is we need to figure out the base area. Our base in this problem is a rectangle with side lengths of 4 and 1. So all we have to do is multiply 4 feet by 1 feet. So we get a base area of 4 square feet. So now we're going to use our formula. The volume equals 1/3 the base area times the height in order to find the volume. So the volume is going to be 1/3 the base area of 4 times the height of 6, and then we end up with a volume of 10 cubic feet. Now we're going to look at the problem in a slightly different way. Example 2 is going to show us how we can find the height if we know something about the base and we know the volume. And in this problem, part A, we notice that the base is a triangle and it has an altitude drawn inside of it. The base of the triangle itself is 24 meters long and the height of the triangle is 8 meters. So we are able to figure out the base area of that triangle. Remember, the area of a triangle is just 1/2 base times height. So our base area is 1/2 of 24 times 8. And that is equal to 96. And that would be square meters. But now the volume itself is going to be 384. It's given to us as that. And we know that's 1/3 the base area times the height. So the number 384 is in the formula for volume and the 96 is in the formula for base area. Now we just need to solve for the height. So 384 is equal to 32h, and then dividing both sides by 32, and h is going to be equal to 12 meters. So we accomplished something different using the same formula. I want you to try B. I'll give you a minute. It is okay in this problem for you to assume that that base is a rectangle. So let's find the base area first. Well, it's a rectangle, so its area is just going to be 4 times 3, which will give us 12. And then we're going to use the volume formula, where volume equals 1/3 the base area times the height. And we start with volume, which is 50 centimeters cubed. So we'll write 50 is equal to 1/3 the base area, which is 12, times the height, which is what we don't know. It's marked with an X in this figure. Little simplifying on the right-hand side, and we get that 50 is 4x, and just dividing by 4, we can get that x is 12.5 centimeters. On this next slide, we are given a pyramid with a square base, has a volume of 128 cubic inches and a height of 6 inches. Now we want to figure out the side length of the square base. Well, we know our formula is volume equals 1/3 base area times height, and we know the volume and we know the height. So let's write down what we know. We know the height is 6 inches, and we're going to use x to represent the side length of the square base, and write down that the volume is 1/3. The base area will just be x times x since it's a square, so x squared, and the height is 6. So now we just need to solve for x. We can start by simplifying. 1/3 times 6 is 2, so we have 128 equals 2x squared. Divide by 2, and we get that x squared is 64, and then we take the square root to find x. And x is going to be 8 inches. So the side length of the square is 8 inches. Here is a pyramid with a rectangular base that has a volume of 6 cubic feet. The length of the rectangular base is 3 feet, and the width of the base is 1.5 feet. So let's find the height. You try this one yourself, and I'll be back in a minute. Okay, the base area is 3 times 1.5, and that will give us a base area of 4.5. That was simply a rectangle, so it was very easy to find. Now, since we know the volume is 6, we know that that volume will be 1/3 the base area times the height. So 6 will equal 1/3 that base area of 4.5 times h, the height. Do a little bit of arithmetic here, a little bit of solving. We'll multiply both sides by 3. And then divide both sides by 4.5. And we end up with a height of 4 feet. Here we're going to be looking at a new concept, and that's what happens when you have similar pyramids. If two pyramids have equal ratios of corresponding linear measures, such as heights or base dimensions, they are called similar pyramids. If two similar solids have a scale factor of k, then the ratio of their volumes is equal to k cubed. So on this example, we are given pyramid A and B are similar. So we want to find the volume of pyramid B. Well, we can look at pyramid A and see that it has a volume of 125 cubic inches. Pyramid B is the volume we're trying to find. We know that the height of pyramid A is 15 inches and the height of pyramid B is 10 inches. So I'm going to compare pyramid B to pyramid A to get my scale factor. It's going to be 10 over 15. It's okay if you did it the other way, as long as you're consistent throughout your problem. If you did 15 over 10 and just stuck with having the bigger pyramid on top and the smaller one on the bottom, that would be just fine. So that is the scale factor of the heights. But we need the scale factor of the volumes if we're going to find the volume of pyramid B. So the scale factor of the volume is the scale factor of the sides cubed. So when you cube 2/3, you get 8/27. Now that we know the scale factor of the volumes, we can compare the two volumes, set them equal to that scale factor, and find the volume of pyramid B. So 8/27 is going to be the volume we're looking for, the smaller pyramid on top, divided by the volume of the larger one, 125. So you can cross multiply, and you get that 27 times the volume is equal to 1,000. Divide by 27, and you end up with 37.04 cubic inches. Don't forget that you have to cube the scale factor of linear measurements in order to see the scale factor of the volumes. Example 7. Square pyramid A and B are similar pyramids. The height of pyramid A is 6 inches and the height of pyramid B is 15 inches. Given the volume of A is 312.5 inches cubed, find the volume of pyramid B. Okay, so you can see that it says pyramid A is 6 inches high and pyramid B is 15 inches high. So if you want to label these figures, the one on the left would have to be A and the one on the right would have to be B. And what would the scale factor then be? 6 to 15, this time we're going left to right, 2 to 5. That's our scale factor of our heights. But remember, we need the scale factor of the volumes to determine the volume of pyramid B. So we are going to take 2/5 and cube it. See if you can set up the rest of the problem. Okay, we need to cube that. So we get 8 over 125 is equal to 312.5 over V. We found the ratio of the volumes, and now we're setting it equal to the ratio of the two pyramids. Remember, pyramid A was the smaller one in the numerator, so that's where we're going to put the volume of pyramid A. And pyramid B, the bottom one, will have the volume V. So solve the equation. Find V. Okay, so we know that cross multiplying 8V is equal to 39,062.5. Divide by 8, and you get a volume of 4,882.8 cubic inches. This time we're asked to find the volume of a composite solid. Well, if you don't already know what the volume of a composite solid is, I'll explain it to you now. You can see that in this picture, someone took a rectangular prism on the bottom, and then they put a triangular pyramid on top of the rectangular prism that just so happened to have a base exactly the same size as the rectangular prism. So a composite solid is whenever you take two solids and you put them right next to each other, so they abut each other. Then, when you're asked to find the volume of the composite solid, you can look at it and see that none of the volume in the pyramid is also in the prism, and vice versa. Therefore, you just have to find both volumes separately and add them together to figure out the total volume. So we're going to start off by finding the volume of the prism. The prism has a square base, so it has base area of 12 times 12, and it has a height of 9, so its volume is 1,296. Now let's do the volume of the pyramid. That will be, and of course it's meters cubed, the volume of the pyramid will be in order to do that first, we have to figure out what the slant height of the pyramid is, or what the height is. Okay, so in order to do that, we need to know that h squared plus 36 is equal to 100. Because that is marked with 10, it's hiding behind something on my screen right now, but there's a 10 for the slant height, right? So it's 10 squared or 100. So we can figure out h using the Pythagorean theorem. So subtract 36 and take the square root. Now we know the height, it's 8. So let's go ahead and find the volume of the triangular, or of the rectangular pyramid, So it's going to be 1/3 its base area, which is still 12 times 12 or 144, times the height, which is 48 times 8, which gives us a volume of 384 cubic meters. So the total volume is going to be the volume of the prism plus the volume of the rectangular pyramid, which gives us a total of 1,680 cubic meters. Here is another composite solid. This is a triangular prism with a triangular pyramid sitting on top. I'm going to give you some time in order to try to figure this out yourself, and then I will come back. Okay, I hope that was enough time for you to complete the problem. Remember, we're going to have to find two separate volumes and add them together to get the total volume. So the base area of the triangle on the bottom is 1/2 of its base, which is 8, times its height, which is 4, or 16 square feet. So let's figure out the volume of the triangular prism. It's going to be 16, that base area, times the height, 5, or 80 cubic feet. So one down, one to go. Now we're going to find the volume of the upper pyramid. Now if you take a look at the upper pyramid, it has the same base as the prism below it, doesn't it? So it also has a base area of 16. And it has a height of 3 as marked on the figure. So the volume is going to be 1/3 that base area of 16 times the height of 3, which gives us 16 feet cubed. The total volume, therefore, is going to be that 80 cubic feet plus the 16 cubic feet, or 96 cubic feet. Thank you so much for coming and checking out the lesson for today. If you have any questions, you can contact your teacher and maybe have a Zoom session, or you could just ask a quick question online. Thank you so much. Bye.